Hello everyone, welcome to our demo video on detecting attacks of XAI systems. In this video, we will walk you through how attackers can manipulate AI models, not by causing them to just misclassify, but also changing their explanations. So these are known as scaffolding attacks, and they can quietly undermine trust in AI systems, especially in critical areas like network security. What is explainable AI? So, the use of AI in network security is growing rapidly, faster than we ever expected. But as AI systems become more complex, they get hidden under layers of abstraction, making the decision making processes hard to understand. We have seen that in ChatGPT and many other modern AI models. In an Ipsos survey, 59% of people in the US are concerned about not understanding how AI algorithms work. And sometimes that lack of clarity is unintentional, but in other cases, it can be intentional. A scaffolding attack is a stealthy form of adversarial manipulation where an AI model is modified to produce misleading explanations while keeping its predictions the same. This tricks popular post-hoc explainable AI tools like Lime and Sharp, making the model look trustworthy to auditors. The attack begins during the training, where a scaffold is secretly added to the model. This scaffold detects when an explanation tool is probing the model and responds with fake but convincing explanations. So it might favor affiliated services or suppress competitors, all without raising red flags. In some cases, it can even open the door to unauthorized access, like backdoor attacks. Because the outputs look correct and the explanations seem valid, these attacks are incredibly hard to detect, making scaffolding a serious threat to AI transparency and trust. In the detection of this attack, we introduce a simple technique to detect these hidden manipulations in a model using just the model and a small real-world dataset. First, we run the normal data through the model, then send in slightly perturbed data like what XAI tools would use. If the model is scaffolded, it reacts differently to the two inputs. This difference shows up clearly when we compare the outputs side by side using a lightweight metric like Hellinger distance. It's fast, efficient, and reveals what explanations alone might miss. Now, looking at the results, as shown in the graphs, the statistical distance between outputs from real and perturbed data is much larger when the model has been tampered with, as shown by the blue curve. By varying the input perturbation, we see this distance decreases in the scaffolded model, while in the control model, it increases. The control model is shown by the red curve. So this clear contrast lets us detect scaffolding just by looking at the slope of the curve. It's fast, a simple method that doesn't need access to the model's internals, and it works reliably across different datasets and attack types. Now, let's move on to the demonstration of using our API to do the exact same task with a browser interface. All right, now that we have seen how to detect scaffolding attacks in theory, let's see how you can do it yourself right from a simple web page. So here we have our demo interface. It's super easy to use. All you have to do is upload the model that needs to be tested. You can use a .pkl, a pickle file. Then enter the standard deviation values that you want the model to actually calculate. And you need a small set of data. So you can upload this data in two parts. First, you can have some hands-on real-world data. And then you'll have to upload the labels for the dataset as well. Now, if you do that here, we have the model file here with us, model.pkl file, and let's have the standard deviation from 0 to 1.5, and let's upload the test dataset here, and let's upload the labels. So once you do that, you can click on the check for scaffolding key here, the button, and then it would take some time to calculate this. but it will then return to a screen where you will see the graph. So once that's done, behind the scenes, our server runs both the real and perturbed inputs through the model, then compares how the model responds to each generated datasets, and the detection result plot is shown here. If there's a suspicious difference in behavior, then we can observe this plot and decide whether it is a scaffolded model or not. So in this curve, it shows that the change in the Hellinger distance between the output of the real data and the output of the perturbed data is actually a negative slope. So it shows the same properties as a scaffolded model, which is uh, having a negative slope. So then we can say that the model has a significant probability of having uh, a scaffolding inside. And if we want to try this again, we can press this button and then go back and then do the experiment again. There we go. So with that demonstration of our API, we come to the final part of this video. So before we wind up, we would like to recap from the top. So we showed that the scaffolding attacks is a possible threat in the 5G and beyond era of telecommunication with AI. And we showed that this attack is successful in a network intrusion detection system, and the detection of this attack is also possible with a simple technique that we introduced. And finally, we demonstrated the working of an API used to detect the scaffolding attacks of a model that the user can upload. Thank you very much, and we hope you gain some knowledge, and we'll see you in the next videos.